Um, if you guys look at your calculator, there's a log button, right? What does it say right next to it? To the right? It looks like IN, but it's actually LN. LN stands for the natural log. Now that button, it does some stuff for us, but what I really want you to understand today is what the heck a natural log is. A natural log is just a special log. So we learned yesterday that logs have bases, right? Every log has a base. So if I was to write log of 10, for example, what's the base of this log when it's blank? 10. Okay, so we already know it's a 10. I want to tell you another secret. Do me a favor in your calculator. Put in log of 10 and then hit equals. Yeah. I'm going to tell you a secret that's going to come up later in the notes. This is a log property that's very useful and helpful to us. If your base matches this, the answer is always 1 as long as there's no exponents. You saw that in yesterday's assignment. Yesterday's assignment had these two things matching. I think they were 5s. And then it had an exponent like 0.29 or something like that. The answer was just 0.29 because these two things, they just turned into a 1. So the connection that logs have to natural logs is that a natural log is just a log of base E. Now, what the heck is E? E is a number. It's a special value. I don't want to get into how they found it, but it's roughly this decimal right here. So it's just a special log, and it's helpful when we solve like real life problems. And that's the extent that you need to know what E is all about. So if you ever see a natural log, sometimes it's helpful to change it to a log base E instead. In fact, the first part of your entire assignment is to just convert it from a natural log to a regular log. Now, all of the rules are exactly the same. Think about the conversion that we talked about yesterday. Didn't we just take the exponent and the number on the right and switch them? It's the same exact thing. The only thing is now we're going to go like this. We're going to say log base E, and we're going to do the same rule from yesterday. So we're going to put the 8 right here, and then we're going to put the 2.08 right here. The only thing that's different is because it's log base E, we don't leave it like that. We change it into natural log. Now I know it looks like an IN, but it's actually an L. It's a lowercase l. So we would just put ln 8 equals 2.08. So when we do these conversions, it's helpful to turn it into the log base E first because that's the same rules that we were using yesterday, and then just change the log base E to the ln instead. And there's nothing special about this. So let's take a look at this next one. The next one, very similar. So we go log base E first, and then we switch these two guys. So we got the 100 right here, and then the 4.61 right here. Now all of our examples, well, they're kind of mixed up because now there's already natural logs and they want us to go the other way. Let's do all the other ones first. So I'm going to give you like, I don't know, I'll give you 30 seconds to do this one and this one. I'm also going to tell you this, you guys. No one ever leaves it as log base E. If there's ever a log base E, always change it to the ln instead. Now I'm doing this sort of as a process. I'm not skipping any steps. So the first thing I do is I go log base E, and then I switch these two things. So I put 20.1 equals 3. And then the part that we need to understand today is that we don't write this. No one ever writes it like that. So that part right there, that just changes to ln. 20.1 equals 3. And once you guys get comfortable and used to this, you could technically go straight to that. If you ever see an e in the problem with an exponent, that's just going to turn into ln. And then you can just switch these two guys. So it would be ln of 1097 equals 7. That's if you're super comfortable with it. If you want to show this extra step, log base e 1097 equals 7, that's fine. However you want to do it is fine with me. Now, if you guys notice the other problems, 7 and 8, I kind of didn't make you do them because they had fractions in them, but it really isn't that big a deal because you do them the same way anyways. This one is log base e, and then we just switch these two things. 1.65 equals 1/2. And we never leave log base e, so we just change it to ln 1.65 equals 1/2. Now wait a second, did you guys catch that I said 7 and 8 are both fractions? You guys notice I said that? I said that on purpose. Do you guys know that radicals are just fractions as exponents? I hope so, because that was in first semester. Some of the stuff from first semester, not a lot of it, but some of it does come back. So in this problem, we want to convert this so it has an exponent instead, because that's what logs are all about. In first semester, we learned that radicals are just exponents that are fractions. So if you remember first semester, we used to go like this and put a slanted fraction. Oh, yeah. What number goes on the bottom? 3. Yeah, it's going to be the 3. What number would go on the top? Yeah, it's going to be a 1 because this e has a 1 on it. So it's just e to the 1/3 equals 1.40. And now that it's got the fraction, now we can do the log stuff because that's what logs are all about. They're just exponents. So we're going log base e. And then we have to switch those two, so it's 1.40 equals 1/3. And then we get rid of any log base e's and turn them into ln. There's our answer. Okay, so the next two problems, number 3 and number 4, we kind of did them out of order because when we convert into a natural log, we need to have the exponent there. Now we need to go backwards. So we need to rewrite these two problems so that they have exponents in them. Now the strategy for this is we just got to figure out what the base is. Because the strategy is pretty much the same. You just switch these two things, but you have to remember what the base is. So if we were going backwards, natural log means log base e of 1/3 equals negative 1.10. So think about the sticky notes that I did yesterday. The 1/3 is the sticky note and negative 110 is the sticky note. So we would switch those two things, but e would become the base. So it'd be e to the negative 1.10 equals the 1/3 because it's just these two things that are switching. And the next problem is exactly the same. I mean, if you really wanted to, you can put the e to the negative 2 up, or you could just leave it. I don't care. So this is log base e of 1/e² equals negative 2. So all we want to do is switch these two things. So if we're going from log to exponential, this thing right here becomes the base that's going to have the exponent on it. And then these two things need to switch. So we have negative 2 to the 2. I don't like how I wrote that. Let me fix that. Looks like I have a negative, but it's not. It's e to the 2. So again, guys, natural log is just a special log. If you ever see a natural log, it just means log with the base of e. If you need to convert, it's helpful to see the log with the base of e. Oh, I forgot to finish this one. Did I erase this one or something? This one's supposed to be ln 100 equals 4.61. The whole point is to turn it into the ln anytime you see log base e. The rest of the stuff that I have to show you is just pretty much calculator stuff. So if you guys will turn to the next page. The next page is where to find this stuff in the calculator. So you already saw at the beginning of the lesson, the natural log button is located right next to your log button. And yes, sometimes you will have to type in E. To access E, you hit the Shift button first and then the LN button. Now, whenever you do that, it's automatically going to do this, I think. It automatically puts a little box there. Every calculator you work with will always put an exponent after it. If the problem just has an E, what's the exponent? It's just a 1, yeah, so you just type in a 1. So this right here is just typing it in the calculator. That's all you have to do is type it in and tell me what the decimal is. Because chances are, E is a decimal, so chances are a lot of these are going to be decimals. Very likely. This one? 0.149. Okay. How about number 3? Type in natural log of 33.
There's still 3 numbers after this.
Yeah. 3.496. Oh. I was a little excited. I thought I said 3.456. That's so cool. 3, 4. Never mind. I can't. I'm a simple man. Okay, so that's easy, right? We don't have to do the other 2. But let's get into a word problem. Now, I've tried to explain word problems a certain way. So let me refresh your memory, especially if you weren't in my class last semester. A word problem, they're always going to give you a formula. That's the nice thing about lower level math classes. You don't have to create the model. They'll always give you the model, and then you just go from there. So basically, they're going to give you a formula. Every formula has lots of letters in it. When you guys get problems that are application or what you guys call word problems, if you just count the letters, they're always going to tell you every letter's value except for 1, because it's our job to figure out the last letter. Now, in this problem, there are actually, it looks like there's 4 letters, but there isn't. There's actually only 3 letters. This problem has the A with the little 0 at the bottom, and the H. Bless you. Now, E is not a letter, right? E is a number. It's that decimal that I showed you on the front page. So that's why I said there's only 3 letters here. So I'm not even reading the problem. I don't even know what it's about, but I told you, if it has 3 letters, they're going to give you 2 numbers. It's always done like that. So here's my 2 numbers. So now I just have to figure out what do those 2 numbers represent. The nice thing is that all of this stuff is broken down. They tell you what every letter means. A represents the area of a wound. T represents how many days have passed. And then A, this is called A sub 0. Some people call it A naught. Is the initial wound area. Huh? Oh, that's a typo. Yeah, this H right here is supposed to be a T. I forgot to fix that from last year. Okay, so now it's a matter of figuring out what the 4 and the 14 represents. I think 14 is the easy one, right? Yeah. 14 is T, because that says right there T days. And then the 4, it says right here, the initial wound area. So that's not the A, that's the A sub 0. So it's this one. So now all we have to do is put the numbers in. And I think in the beginning, especially since we haven't really solved problems, it all ends up just going into calculator. So watch this. We don't know this. We know that this is 4e negative 0.05 times 14. And guys, if your only letter is on the left, all of this is just a calculator question. Just put the whole thing in the calculator exactly how it looks. So I think that's what it ends up being, hopefully. Is that what you guys got? You know where I got the centimeter squared from?
From the question.
Kind of, yeah. Well, yeah, it says square centimeters. But I know that area is always squared, no matter what the units are. So if you see any measurements inside of that problem, just put the little 2 on it, and that's what your area is always going to be. And that's pretty much it. So can someone tell me what a natural log is? Yeah, well, we just say E, right? Yeah, that's all it is. If you see natural log, it just means log base E. So if you ever get confused, you can always just change it to that instead. And so that's it. Now, the last 2 days' notes, I don't know if you've noticed, but the goals are how the assignments are broken up. So goal 1 is the first chunk of problems. Goal 2 is the second chunk of problems. And then goal 3 is the third chunk of problems. So that's it. You guys have about 20 minutes to practice this stuff now in the assignments.
The whole time?
Let me look at it. I don't remember. Let me pause this too.